We will be doing the can crushing experiment, and to do this we need an empty Coke can, some water, an ice bath, and we've got some water boiling right now. We're going to take a tablespoon of water and put it in this can. Might move around in the pan, so if you want to just hold it. You're going to place it in the pan and wait till you see a little steam come out of the opening. And it might take a while. I don't know if you can tell, but there's a little steam coming out of the opening. And once you start seeing that, you should wait probably about like 30 seconds just to make sure the water's hot enough. To explain the can crushing experiment, say we have a can. Inside this can, you have internal pressure pushing outside and atmospheric pressure pushing inside. So this should be balanced, but what happens when we put the can in an ice bath? When you put it in the ice bath, we're going to seal the can off, and the internal pressure will decrease because water vapor will begin to condense. And as it condenses, there will be less water vapor, thus less pressure pushing outside, and the atmospheric pressure will then overcome the internal pressure, causing the can to crush. So we have a dented ping pong ball, and we are going to correct it by placing it in the hot water. And almost there.
To explain Charles's law, we did the ping pong ball experiment. So as the temperature increases, the volume of the ball will increase, and so that's how we fix the dent of the ball. This experiment is to demonstrate Boyle's law. So in the first trial, I'm going to compress the volume of the syringe. So you start with the valve open, and so when it's open, the air can flow freely, but when you close it, it'll lock it so no air can escape. So you put the marshmallows in, and you lock the valve. And so as I compress this, the volume in the syringe will decrease, so that means the pressure will increase, and the volume of the marshmallows will decrease, which means they'll shrink. Let me see. Okay, so again. Good. Okay, so for the second trial, we're going to increase the volume of air in the syringe. So again, you lock the syringe, and as the volume in the syringe increases, the pressure will decrease, so the volume of the marshmallows will increase, which means they'll grow larger.
We will be demonstrating Avogadro's law using some balloons, some water, and some Alka-Seltzer. In this red balloon, we're going to put 1 tablet of Alka-Seltzer and some water. In the blue balloon, 2 tablets and some water, and in the green balloon, 3 tablets and some water. So here's 1 tablet.
Close, close, close. Do you feel it?
There's 1. Now we're going to do 2 tablets. I'll just put it directly.
I can try to try it this time.
No, that's okay. the blue one?
3 tablets.
Add more water.
So here are 3 tablets.
Sorry. Okay. There's 3 balloons. This experiment should show that as you increase that number, the more particles, its volume should increase.